So good afternoon, one and all present here, and to all the welcome all the participants who are there live on YouTube. And we are fortunate enough to have an eminent guest with us, Dr. Asim Tiwari sir. I welcome you, sir,
Thank you.
in this program. Today is the day 5 of our. So I would like to introduce sir first. Dr. Asim Tiwari is professor in UIT RGPV. He is having over 30 years experience in the field of mechanical engineering. Sir has 20 plus research papers. Out of that, almost 5 6 papers are SCI and other are also in reputed journals. 5 candidates has been Sir has 3 patents in the conversion technology from diesel engine to petrol engine or dual fuel mode. Sir is also the professional member of professional bodies like ASME, ISTE, uh, SESI, Society of Automotive Engineering, and Sir is Dean of Faculty of Engineering Technology. Sir is member of University Executive Body of University RGPV, and Sir is Board of Studies member of almost all the government colleges of Madhya Pradesh, which are autonomous bodies. Sir is the reviewer of many journals, many editorial boards, and research areas of interest are alternate automotive fuels, eco-friendly refrigerants, air curtains, and digitization is the subject in which sir has deep interest. And one more thing about sir is apart from his technical knowledge, sir is a very good motivator and orator also. Sir has worked for Gyanvani educational channel of IGNU for many years. Sir has on-air recording of 25 hours for radio counseling of these students. So we are blessed, or we are so glad, sir, so that that you are here. So we will be getting some
Thank you.
bit of your knowledge. So over to
Thank
you,
you.
sir. Thank you so much for that.
Thank you. Thank you. Thank you for a wonderful introduction of mine. I hope I am audible clearly to everybody. And this topic I have included today is the introduction about the electrical vehicles, and we'll be talking the basics of the electrical vehicle, the challenges and the opportunities in the field of electrical vehicles, and what is the government policy which is coming up in India connected to the electrical vehicles, and what are the things which are going on. So in a nutshell, it's a very beginners presentation. It's a presentation for the beginners, and we start with this presentation with this slide. I'm sorry, the slide is not moving. Why it is got hanged up? Sorry. I got hanged up. I'm sorry. I'm again presenting. Again starting the presentation. It was like hanged up, and कोई बात नहीं. Starting again. Yeah. Is it visible?
Yes, sir.
Visible. Okay. So I'm making it full screen now. Hope this will be moving. Yes, this is moving. Now the electrical vehicle, first of all, the definition of the electrical vehicle is the one that operates on electrical motor instead of internal combustion engine. So this is the main change of between the ICE and the ACE. The electrical vehicle, the heart of the electrical vehicle is the electrical motor, which is powered by the array of electrical batteries instead of internal combustion engines. This is arised because of so many issues, and the issues include the rising pollution because of the emission of the vehicles, then the global warming. The emissions are causing the carbon dioxide secretion, and carbon dioxide responsible for the global warming, depleting natural resources because we are continuously using the petroleum products, and that causes their exhaust. They're at the verge of exhaust now. The petroleum products are depleting, and they're almost at the verge of finish. Rising carbon footprints, when footprints of carbon are rising, and that is again the environmental impact on the fuel-based vehicles. Now it is so, because of all these main four regions, it has drawn a considerable amount of interest amongst in the past decade. So now the electrical vehicle is the one that uses one or more electrical motors or traction motors for propulsion. An electrical vehicle may be powered through a collector system by electricity from off vehicle source, or maybe say self-contained. There are two ways you can power the electrical vehicle. One is the you can power it with the by plugging in with the with the source of power, and that way it becomes stationary because you cannot move it. So make it a vehicle. You need a self-contained battery with the vehicle itself. When you're using the battery, the portable battery with the vehicle itself, then you'll be in the vehicle mode. So the popular mode is a self-contained with a battery, or the solar power, or an electrical generator to convert fuel to electricity. So you can use the solar panels also, and at the same time the solar panel can be used in two ways because they cannot generate so much of the power. So with this can which can energize the motor, but it is used to recharge the batteries which are there, or vice versa here. But if you use directly the solar panel to run the vehicle without in between, without any interface of the battery to that thing, that becomes a solar car. But that is not possible because you need a lot of area for that purpose. So that will not be very feasible alternate, and still the searches are going on. They are not very successful, that type of exclusively solar powered one, not having the batteries. That is still in the process of research. So next is the history. Whenever we start a topic, we talk about the historical perspectives of the thing. So we start with the history of the electrical. This is a chronological order of the various steps of progression in the realm of electrical car. Now it is started in the 1830 with the first electric carriage was built. In 1891, the first electrical automobile was built in the United States. In 1900, the heydays started. 1908, the Henry Ford, the top one, the black and white image. You can see the Henry Ford introduced the Model T. That is top image we can see here. Then the progress started, and gradually the things are changing from that Ford vehicle to the one which we can see in the bottom picture, the red one. So 2007, the Tesla Roadster, the very famous Tesla Roadster, came into 2007. Now let us talk about the Indian policy scenario. What is the Indian policy in the field of the electrical car? Because India is also not way behind in the electrical cars. They are all also doing good, and the government is very supportive, and government has got policy which are in favor to the electrical vehicle things here. In India, the first concrete decision to incentivize electrical vehicle was taken in 2010. According to that, this 95 crore scheme approved by the MNRE, the Ministry of New and Renewable Energy, the government announced a financial incentive for manufacturers for electrical vehicles sold in India. So this is the first step was in the year 2010, where MNRE announced the financial incentives. That's the first step. Then the scheme that came in effective from November 2010 envisaged the incentives up to 20% of the ex-factory price. That was the scheme actually which came. 20% of the ex-factory prices of the vehicle were borne by the government, subject to the maximum limit. Obviously, it had the maximum limit also. However, the subsidy scheme was later withdrawn by MNRE in March 2012 because of the subsidy schemes are already not very popular. In 2013, the government of India unveiled the National Electricity Mobility Mission Plan. This is very important. NEMMP, these are the NEMMP and FAME. These are the words which are the quick words, quick ready reckoner words for the government policy in India. NEMMP and FAME. FAME we will talk later. The National Electricity Mobility Mission Plan 2020 to make a major shift to electrical vehicle and to address the issues of national energy security, vehicular pollution, and the growth of the domestic manufacturing capacity. So they have done two things. They have given the financial subsidy, and they have also supported the infrastructure. They create a supporting infrastructure for e-vehicle. The two-way, any MMP was there to support the manufacturer in two ways, offering the subsidy, and second point is the creating the supporting infrastructure for e-vehicles. So again, these are the 2 points which were given to the given these 2 points were unveiled by the government of India in 2013. Now for the plan mostly remained on paper. This couldn't be materialized, and then later came the union budget in 2015-16 in parliament. Then that time the finance minister late Arun Jaitley announced a very popular scheme, that was the FAME 1, and still we are in the FAME 2 stage here. The FAME is the faster adoption and manufacturing of electrical vehicle. That was the scheme. That was a very famous scheme of government of India, and still we are in the FAME mode itself. And now they call it this present time as a FAME 2 stage here. The faster adoption and manufacturing of electrical vehicles, called popularly called as FAME, with an initial outlay of about 75 crores. The scheme was announced with an aim to offer incentives of clean fuel technology cars to boost their sales to up to 7 million vehicles by 2020. It didn't work. What they planned in the FAME, it didn't work because we don't have the 7 million vehicle in 2020. What we have, again, this is frozen. This presentation freezes. I have to restart again. Yeah, now it is again visible. Presentation is visible. Yeah, in 201, the presentation is visible.
No, sir, right now it is not visible.
Not visible, but I have to share the screen again. So
Yes.
this is the issues which are going on. So I share it again. The sharing the screen, and this the screen and share, and yeah.
Yes, it is visible.
It is visible now. This is what is happening in the network. Problems are coming in between all the time. So we are in the E mood, and sometimes it is rainy season. So basically, the network issues are there everywhere.
Yes.
And in my house, I don't know, network issues are not very pronounced, but sometimes it is like that only. And in between, I tell you in advance that the electricity cut may take place, and I may be out also. So that, be ready for that. If you find me all of a sudden out, then you come to know that the electricity is supply is not available. Then I will join by battery, and this then this the net, again by tethering from the phone, that I'll do that, and again I'll rejoin again. Don't worry, we have got for every problem we have got a solution. In
Yes.
2017, transport minister, in 2015 the FAME failed. In 2017, Transport Minister Nitin Gadkari made a statement showing India's intent to move 100% electrical car by 2030. This was very controversial decision, and it was raised a huge concern all over. People were agitated. People were like, how we can do it in 10-year time, and all automobile manufacturers were like agitated, and then there was a huge pressure on the government, and the government subsequently diluted its plan 100% to 30%, and I hope it will be further down, maybe 100% to 25% to 20% by 2030. So this is the another milestone in the government policy, because we are talking about challenges and opportunities. So these are the challenge government policies and all the opportunities and challenges. They always talk about the opportunities and challenges, because policies are the most important thing which creates the opportunities, and which also make us to face the challenges. In February 2019, the Union Cabinet cleared a 10,000 crore program under FAME 2. I told you that there was a FAME 2 again. This scheme came into the effect in April 1, 2019. The main objective of this scheme is to encourage a faster adoption of electrical and hybrid vehicle by offering upfront incentives. Incentives, not the more pronounced incentives that they want to offer. In the FAME 2, they wanted to offer more pronounced and the upfront incentives on purchase of electrical vehicle, and also by establishing a necessary charging infrastructure for EVs. This is very important, that not only for purchasing the electrical vehicle, but you must have. Then again, this is frozen. This freezes. I have to stop and again this thing. Uh, uh, Reshare the presentation. So this is what it is happening here. Again and again, I have to share the screen. So this one is the shared again, and I think this is again visible. Visible.
Yes, sir. Yes, sir.
I make it full screen. Yeah, into this is going to happen again, I think so. Be ready for this type of thing. Supporting fame, the CM of Delhi on 7th August 2020, Abhi, a few days back, he said that he is going to do the 25% of the vehicles in the Delhi by 2024, and at present, but they are having only 0.2% electrical vehicle in the Delhi, because Delhi is a highly polluted city. So they want to convert this automobile sector into the 25%. They want to convert into the electrical mode by 2024. But this looks again very challenging, because at present they have got only 0.2%. No, BHEL is coming, BHEL, the Bharat Heavy Electrical Limited is coming up into the picture. They are pivoting from power sector to transportation. They see that the power sector has come into stagnation, so they want to switch to the transportation sector, and they have tied up with the collaborative tie-ups with the Ashoka Leyland and the Tata Motors. So they wanted to and in foreign collaboration also they did with Hitachi Transportation Company and Mitsubishi Heavy Industries and the Skoda. So a lot of tie-ups of BHEL. So they also want to run into this the electrical vehicle bandwagon. They want to join that. 26th August, Mahindra and Mahindra, to one day back, yesterday, Mahindra and Mahindra has signed an MOU with the Tel Aviv-based Israeli RWE Automotive to explore production of electrical commercial vehicle. This is very important, because the best technology of the world is in Israel. So they have signed a MOU with the Israel, with the Tel Aviv-based RWE Automotive company, and this will, I hope this will switch on, and they will have the startups and to explore the development of manufacturing of electrical commercial vehicle for global market. So this is what the Mahindra and Mahindra has said in their statement. Now the components of it come on the technical points here. The components of electrical vehicle. So we've got the battery. Obviously, it is on the bottom of the this. Can you see my this cursor moving on the screen? Cursor is visible, please. Cursor is visible. So this is the battery array, which is at the bottom of the car. Then we have got the electrical motor, which is powered by the battery, and in between we have got the power electronics systems here. We have got the inverter here to convert the DC into AC or vice versa. And then we have got drivetrain. What is drivetrain? Drivetrain is a combination of the battery, clutches, and the transmission system. It's a combination of these things is called together called drivetrain. So then the charging station. So one more better this component photograph is here. You can see this battery array on the floor of the battery. This is a traction battery pack here. It's called traction battery pack here, and there is an auxiliary battery over here. If you can see my cursor here, auxiliary battery over here. Then we've got charging port connected to the battery, which externally can be plugged in from this cable, and this battery array can be charged whenever needed. Then we have got the power electronic controller here, which is controlling the need of the power which is being supplied by the battery to the traction electric motor. This is red one is the traction electrical motor. You see directly, it is almost directly mounted on the wheels. There is no transmission link. it is direct mounting. So transmission links is basically power loss here. If you directly mount the thing onto the moving shafts of the vehicle, you save time, you save power in the transmission, and the transmission losses, you save that here. And there is a DC to DC converter is also there here. We have got a converter here. We've got a power electronics controller and a thermal cooling system, which is there to cool whenever. And there's an auxiliary battery also with the system. And there is a, in addition to the this external charging port from this cable, there's an onboard charger also there. This blue one is the onboard charger. So this is onboard charger is also with us. So this is the mechanism, the schematic of the whole thing here. Now we talk about the components in detail. The battery is, it powers the electrical motor. Its capacity is defined in ampere hour. What is an ampere hour? I would like to talk about the ampere hour. Ampere hour is used to measure the capacity of the battery. A battery with the capacity of 1 ampere hour should be able to continuously supply current of 1 ampere to a load. If a battery is having 1 ampere hour capacity, then it should be able to supply the 1 ampere of the current to the load for 1 hour. If or 2 ampere for half an hour. If you're extracting 2 ampere of the current from the 1 ampere hour battery, then it should be able to supply it for half an hour, or one-third ampere for 3 hours. This is the concept of the battery capacity, because that comes into the picture here. We have to talk about the battery capacity. Whenever we talk about the battery capacity, technical terms comes in the ampere hour here. The power converter, the electrical energy stored in the battery is fixed DC, which should be converted to either variable DC or variable AC. जो भी हमारा requirement है हमारी motor, what type of motor we are using is a AC motor, DC motor, what type of what type of conversion we require. So the converter is there to give us the required conversion, which different models uses different type of the needs. Sometimes variable DC, sometimes variable AC, sometimes all this thing here. So as per the demand, the power converter is supplying them the energy of their demand on this is the another point here. The electrical motor, DC series induction motors were used at the earlier stages. Nowadays they are shifting to the special electrical devices, and they sometimes they use traction motors also. So these motors are there in the trend. Again frozen, this is frozen again, boy, I'm sorry. This screen is frozen. I have to stop sharing and I reshare that. Resharing, then again this is continuously happening because of some issues. So I'm resharing this screen, and then this one. Okay, this is again reshared, and I make it full screen now. So this is full screen, and now this is reshared. Now I can yeah, now this I have done. This slide I have done. So next one, components of the EV continued. So clutch is there. The clutch, purpose of the clutch is to help in engagement and disengagement of the moving part with the transmission system. Moving part in this case here is the electrical motor, and the transmission system includes the later parts of the propeller shaft, differential, and the wheels and everything, links and all those, so many things will be there in the transmission. In between, gearbox will also be there. So connecting the motor with the all transmission linkage, make and break arrangement, they are mostly friction clutches. Is friction clutches, and they, on the basis of the friction, they transmit the power. The transmission is through the gearbox and is called as a transmission, which allows transfer of the power from engine to wheel. So through the gearbox, the transmission system is working. Then drivetrain, I already talked about the drivetrain earlier in my previous slide. The combination of electrical motor, clutch, and the gearbox is referred as drivetrain. It's a set of three things, which is in general called as drivetrain. The set of three things includes electrical motor, the clutch, and the gearbox. These three things together are called drivetrain here. So this is the thing here. Again, it is frozen. My God, this is so it's going to have create problem for me. This is again, I have to reshare. This is some problems are there. I don't know why this is happening. This is maybe because of the some issues of the signals here. And this is the thing. Yeah. Okay, I'm resharing it. Again, I think it's visible,
Yes,
and
sir.
I make it full screen, and then I architecture of the EV. So architecture of the EV is like we have got the energy source battery, which is connected to the charger here. Obviously, battery need to be charged again and again. Then the drivetrain, including the three parts: the power converter, electrical motor, and transmission drive shaft. These three things are the array of these three things called drivetrain. Then the drive control signals, which are coming from the microprocessor, which is supplied to the power converter, which senses the need of the motor, how much power we need in the motor. So the portion of the electric energy which is coming to the power converter, a small portion goes to the motor, and then vice versa, it goes to the further transmission system here. Nowadays, for controlling purpose, they are using the 12-bit, 24, 36-bit microprocessor, and microprocessor controls are very popular in automobile. So the moreover, everywhere in fuel supply, also in the IC engine, also we are using microprocessor in the fuel supply. So which makes the fuel supply proportionate to the load demand here. Another view of the car, how does it work? This is a pictorial view which we have already discussed earlier. Now you see there's a small picture here which is giving the controller gathers the energy from the battery. This is the controller here. It is gathering the battery from this 300-watt battery array. This is the getting the energy from here. Now this controller decides that how much energy it has to supply to the AC motor. This AC motor is here, which is connected to the transmission system here, which I'm moving cursor. I hope the cursor is visible. So battery is connected to the controller is connected to this pedal, the human interface here. When you press the pedal, you are able to activate the controller as per this pedal requirement, as per the requirement of this pedal force. They measure, they decide that how much current has to go to the AC motor, and according to the load need, the current goes from the motor via controller to the AC motor, and that goes to transmission system here. In addition to these all thing here, we have got a charger available, and we have got a auxiliary battery also available over here. So these are the architect and the working of the system here. I hope that transparent that's not frozen. Good, it's not frozen. I'm little fearful because sometimes it freezes, and then I have to again reshare the screen, and then that's it. I mean, no issue. We can do that an n number of times. Main component of EV. They look at this. So now this automobile sector is shifted from purely mechanical sector to almost interdisciplinary sector. We have got the controller, power electronic system, which is coming up in the picture. We are having a lot of electrical things which are coming into the battery and the motor, and everything is coming. This is now the interdisciplinary area. So main components include high voltage battery with control unit for battery regulation and charger. We have discussed that. Electrical motor, generator, and electronics control, power electronics, and the cooling system. And I have shown you that on the figure on the diagram. The transmission, including differential, brake system, air conditioning system, battery operated, including the compressor and all those lines which are used to supply the air conditioned air to the back seats and rear seats and everywhere in the vehicle. Then lighting system, already we have got here. Transmission with differential at the back side. We have got chassis. We need chassis here. We need suspension here. We need a cooling system in order to dissipate the heat sinks at many places. We need in the electronic systems, also in the electrical motors, also we need cooling system sometimes. And the brake, above all, the brakes are needed. So in this case here, the very innovative brakes are used, and they are regenerative braking system which is used here. We'll talk about regenerative braking system later. We need battery charger, we need charging contacts and the external charging source, and in addition to that, the our conventional system, we need a comfortable seating arrangement inside the car which can accommodate number of passengers who can sit comfortably. There we come across the ergonomic concepts here. So ergonomic concepts are there which are applied for the making a comfortable seating here. Now I'd like to demonstrate a small Canadian YouTube film here. It's a 3 minutes duration. So let us talk a basic animation YouTube presentation. Let's tease it. So this is a small film which we have done. I hope it was visible to everybody.
Yes.
And now come back onto the screen sharing, and again the yeah, this one, sharing it again. My presentation is, my presentation is visible.
Yes, sir, it is.
Okay, so there's one more link here which I'm not going to show. You can copy it down or you can see it later on, which is about the Tesla, the how the Tesla cars are working, and the details of the Tesla is a very big name in the electrical car system and electrical vehicle system. So the second link is devoted to the all about Tesla. So we'll skipping that because I would like to speak more rather than showing the films of YouTube. EV has 90% less moving part than the ICE. This is very important. Less moving part, less friction, less heat generation, less wear and tear, and that's very, very encouraging. So breakdown of the parts that keeps an EV moving. What are the important part? Again, very fast. Electrical motor provides power to rotate the wheel. It can be AC, DC type. However, AC motors are more common. The inverter converts the electrical current in the form of, this is very simple. We have already done it, so I skipped to this. And then working of EVs, we have also done this. Just 1 minute. This thing, battery act as a gas tank, and the electrical motor vehicle car acceleration. The controller acts as a regulator. I have done all this thing here. So it looks exactly like the fossil fuel powered car. They look exactly, though the look wise they are same. They don't have the tailpipe and the gas tank, but their overall structure is basically same. Under the bonnet, instead of having huge engine, we have got a electrical motor and a controller. The electrical motor needs no oil, no tune ups, and since there is no tailpiece emission, and this is all about this thing here. The battery power all the electrical device in the car, just like the battery in the gas powered car. Everything else in the electrical car is basically the same as the gas powered equivalent transmission. What are the difference points with the electrical car and the our gas powered cars here? Same things are transmission, same things are brakes, same things are air conditioning, same things are air brakes, same things are suspension, same things are our basically the tire tubes and the electrical wiring almost, and air conditioning, same air conditioning. So these are the same things here. So difference lies only in the engine replacing the car, and the rest of the controls over there. The driver can take advantage of the motor's momentum. This is the new concept I'm talking about. This is all about, I'm talking about regenerative braking. The driver can take advantage of the motor's momentum when pressure is applied on the brake. When you are applying the pressure on the brake, what happens? All the kinetic energy is converted into the heat and friction. So this goes waste in case of our IC engine gas powered cars. But here, this energy, when the brake is applied, the conversion of kinetic energy of the vehicle is converted into the electric energy, and this is used for charging the battery. And this is the process which is introduced. This is the thing, innovative thing which is introduced in the electrical cars, and this is called regenerative braking. So this is a new point which is connected to this here. Electric cars function by plugging into a charger point and taking electricity from the grid. They store the electricity in rechargeable batteries that power an electrical motor which turns the wheel. Electric cars accelerate faster than the vehicle with traditional fuel, so they are lighter to drive. Repetition some, you can charge an electrical vehicle by plugging into there are two ways how we can charge the things, because we are on a long journey. What happens, we are uh, fully charged and we start our journey. What will happen, one moment of time the charging is exhausted and becomes zero charging. Then you have two options. One option is that you stay at that place, you halt at that place, and you charge the battery again for 1 hour or maybe half an hour. Nowadays, yesterday, 2 days, 3 days back, I heard that they are charging it for 40 minutes, 30 minutes, very sharp 25 minutes. They're charging in the full battery. Now, so the technology changing, but some halt will be needed. But if you don't want to halt, so then you must have a ready-made battery, charged one, which can replace the discharge battery. So you just removing the discharge battery and placing another battery, which is a charged one, in place of that, and without halting, you can immediately start your journey. So there are two ways here. I forgot to share a paper. Actually, I have done a paper on the futuristic study of the electrical cars. It's done by one of my MTech student in my college. So that paper title was accepted by a UGC approved journal, and basically will publish soon. And this is futuristic. That is on the futuristic approach. There we have talked about the how the charging stations will work, how they will work, and what are the strategies and all so many things which are all together. You need a separate setup and everything else. So that all about that thing here. Three types of chargers: the 3-pin plug charger, the socketed charger, and the you can see them, and the almost small photographs. And third one is the Oh, again frozen. It's again frozen. I'm sorry. We will again reshare this whole thing, and that will. This is again uh, happening. So no, meeting in progress. No. So this again, I'm sharing it here. Screen sharing. This one. This one. I think screen is again visible, and I'm
Yes, sir.
making it. This is happening quite frequently now. I'm now making it full screen, so that will, yeah, full screen. So components is I have done components, and architecture I have done. Again, I have done this. This I have done. This I have done. This I have also covered up. Yeah, yeah, this I have covered up. Yeah, I have covered up this also. Three type of chargers: the three-pin plug charger, socketed charger, and the third charger. So these are the three chargers which are being used here. Now, three EV charging speeds are adopted in they're popular in the day-to-day life, and they are like slower speed, typically rated up to 3 kilowatt, often used to charge overnight or at the workplace. Charging time is 8 to 10 hours. The fast charging, the typically rated at the either 7 kilowatt to 22 kilowatt, tends to be installed in the car parks, supermarkets, leisure centers, and houses with off-street parking. Charging time is 3 to 4 hours. Now, the rapid one is useful, typically rated from 43 kilowatt onwards, only compatible with EVs that have rapid charging capacity. Charging time is 30 to 60 minutes. So this one is useful. Types of the electrical car, we have got three type of the electrical car. Yeah, reverse. This is the reverse order. If you see the third one, na, that is almost beginning of the IC engine to electrical. The second one is half of the IC engine, half of the electrical, and third one, the first one, which is in the which is plug-in electric, is a pure electric. Plug-in electric is the pure electric. This means that this car runs purely on electricity, and it gets all the power when it's plugged into the charger, and when they don't need petrol or diesel at all here, and it's working only on the battery powered battery, which is kept in the system, which is being carried up. So that is the source of power, lone source. That is a lone source of power. Second is a plug-in hybrid. These mainly run on electricity but have a traditional fuel engine also, so you can use petrol or diesel too. If you run out of charge, if your charging is over and you're stopped, you're standing in between the road, and your battery, your meter is showing the zero charging, then switch to the petrol or diesel, whatever is available. So that is plug-in hybrid concept here. The third one is the hybrid electrical. Hybrid electrical is like almost beginning. These run mainly on the fuel like petrol or diesel. They're purely diesel or petrol car, but they also have electrical battery too, which is recharged through the regenerative braking. Or regenerative braking I have already discussed, and this is, so these let you switch between using your fuel engine and using EV mode. There's the EV mode and the IC engine mode. Whichever mode you select as per your choice, you can have here the torch up button. You can select as per your choice here. So these three things are there. So this arrow shows the direction of increased electrification. From the conventional vehicle, we are moving to hybrid electrical vehicle, and from hybrid electrical vehicle to complete battery electrical vehicle. I have discussed all these three types in the last slide. Braking system I have already discussed with you, guys. Braking in a traditional car and regenerative braking. I have talked about regenerative braking, so I don't need this. So battery is like many types of batteries are being used. Some slides on battery, the acid battery accumulators, lead accumulators, nickel metal hydrides, then lithium ion, very popular lithium ion batteries, lithium polymer, Li poly, then lithium iron phosphate. So these are the popular type of the batteries which are there. We talk something about some slides about the battery stores electricity through reversible chemical reaction. One chemical reaction is used to charge the batteries when you're charging it. and then it is storing the energy in the form of chemical energy, and another chemical reaction that takes place, and that is used to take out the power from the battery, which is a stored one, as a result of the one another chemical reaction here. So this is the anode, which is a carbon one basically, and the cathode, which is metal, either cobalt, manganese, or nickel oxide. So, and the electrolyte is lithium salt in solvent. So this is lithium salt is an electrolyte here. These are the reactions of cathode and anode reaction. We will not go in detail of the reactions here. The battery stores electricity through reversible chemical action, typical lithium ion cell. These are the chemical reaction I'm showing in this slide here. You got the electron coming over here, cathode, and is going to the anode here, and then these are the anodic reaction and cathodic reactions shown over here. Regenerative braking is small uh, sketch showing the concept of regenerative braking, which we have discussed earlier. Now, some vehicles which are there available, Volkswagen e-Golf here, range is 125 mile, equivalent to a journey from Bristol to Snowdonia National Park here. Hyundai Kona Electrical, then Jaguar I-Pace here. These are the data, you can read it. And advantages of electrical cars, so we have discussed so many advantages. No need of up to the 150, 180, or maybe 200, no need of charging, no tailpipe, no harmful emission, no oil consumption, no cost of fuel, which is increasing like anything every day. You listen that the petrol price and diesel price is hiking every day. This is happening. So cars can be recharged whenever it's convenient to be user, most cost effective, regular cars cheaper, and these are the advantages. Global leader in terms of the total units sold, Renault is the top one, Nissan, then Mitsubishi, the General Motors, Toyota, Tesla is on fifth here, and Ford, by BYD, and BMW, British Motor Vehicle, the Greeley Group, and the Volkswagen. Indian scenario, these slides are devoted to the Indian scenario. These are the basically cost range and the range of their power. They show the kilometer, how many kilometers they are discharged, and that cost is on the third column. Then these are the for the motorcycles. This slide is for the two-wheelers, electrical two-wheelers. Then electric bus is also there in the use here, and then they are coming with 31 passenger capacity, they're safe and green buses. Then this I have discussed about you, that how the Mahindra and Mahindra has signed the MOU with the Israeli company Ashoka Leland e-bus. Look at this very fascinating, colorful Ashoka Leland e-bus photograph, which is very costly. Thanks for your kind attention. Now I'd like to switch off here, and I would like to take up the question. If any question is there, then we'll take up the questions, or stop presentation. Yeah,
Thank you so much, sir, for the presentation. I
thank
hope
you.
you have started from the very fundamental. So it
Uh,
would be very nice for the beginners to have the fundamental basic knowledge about this, so that they can go further.
thank you.
Thank you so much, sir, for the nice session. We have a question.
Uh,
Ms. Sangeeta was asking, is regenerative braking system is there? So you have already answered this in your
yeah,
presentation.
I've answered. Regenerative braking is used. It's a very important salient features of electrical car, which is not available in IC engine car. So they are using it. There is a continuous part of there is a compulsory part of electrical cars. It's very good, and it's yeah.
Mr. Mahesh Kumar is asking how to save battery energy in ideal mode or in traffic
Yeah,
mode. Is it
yeah,
possible?
yeah. See, it is moreover safe, but the things are happening. I came across the reports of accidents here, especially in rainy season, or especially when you हमारे इंडिया में क्या हो रहा है, people are running their cars on 6 inch 7 inch उसके ऊपर पानी भरा है रोड के ऊपर, वो पूरा शॉर्ट सर्किट आता है, जाम हो जाते हैं, electrical circuits are all jammed and all current flows in the, because heavy batteries are there, they are like bombs And sometimes I have heard the accident reports from the Western countries, not in our country, that their car exploded like a bomb, because this all you hear that lithium ion batteries people are using in the mobile phone, and because of overcharging and all short circuits, etc., the people have got injured ears, etc. all. So that has happened. The safety, you need to revise the safety norms when you start using the electrical car. The safety norms to be more stringent and more I mean strong for the India, especially because India, we people are like we people only. We don't understand. Whatever we want to do, we do as per our wish. We don't care for the safety norm. We never read the brochures which are supplied. So there should be very stringent safety precautions need to be there. Electrical things are always associated with safety things. The extra safety is needed in all electrical devices. बोलिए और कुछ क्वेश्चन है?
Thank you so much, sir. No, sir, this is all about the questions, and we just would like to share certificates, sir. This is gratitude from our institution for you, sir.
Thank you very much. Very good.
So thank you so much, sir, for giving a wonderful presentation. I hope all the participants has many takeaways from it. Thank you so much.
Thank you. Thank you. मैं स्विच